Welcome to qnawire.
Hello students. In this question, a fuel tank is filled with propane whose mass is given. We have to find out the number of moles of propane. The number of moles is given by the formula mass divided by molar mass. Substituting the value, the mass of propane is 9.8 and the molar mass of propane is 44.01. On solving this, we will get the number of moles of the propane will be equal to 0.223 moles. Coming to the second part of the question, we have to calculate the number of carbon atoms in the given mass of the propane. So the propane has a molecular formula of C3H8. So here for 1 mole of the propane will have the 3 mole of carbon, which is in 1:3 ratio. Therefore, the number of moles of carbon will be given by 3 into number of moles of the propane. Substituting the value 3 into 0.223. On solving this, we will get the number of moles of carbon will be equal to 0.669 moles. Using this, we can find out the number of carbon atoms. The number of carbon atoms is given by the formula number of moles into Avogadro number. Substituting the values, that is 0.669 into Avogadro number is 6.02 into 10 to the power 23. On solving this, we will get the number of carbon atoms will be equal to 4.029 into 10 to the power 23 atoms. Coming to the third part of the question, here the number of moles of the calcium chloride pentahydrate has been given. We have to find out the mass of the calcium chloride pentahydrate in milligram. So for that we are using the formula mass is equal to number of moles into molar mass of the calcium chloride pentahydrate. Substituting the value 0.75 into molar mass of the calcium chloride pentahydrate will be 201.06. On solving this, we will get the mass will be equal to 150.795 gram. We want it in milligram, so we are multiplying this with 1000. We will get the mass of the calcium chloride pentahydrate will be 150,795 milligram. So this is the answer to the third part of the question. Coming to the fourth part of the question, a tank is filled with the carbon dioxide molecule where the number of oxygen atom has been given. We have to find out the number of moles of the carbon atom. For that, we have to find out the number of moles of oxygen atom, which is given by the number of oxygen atoms divided by the Avogadro number. Substituting the values, that is 9.5 into 10 to the power 25 divided by 6.02 into 10 to the power 23. On solving this, we will get the number of moles of the oxygen will be equal to 157.81 moles. For every 1 mole of carbon atom, there will be 2 mole of oxygen atom in the carbon dioxide molecule. Therefore, the number of moles of the carbon will be equal to 1 by 2 into number of moles of the oxygen. Substituting the values, that is 1 by 2 into 157.81. On solving this, we will get the number of moles of the carbon will be equal to 78.905 moles. Coming to the last part of the question, here the mass of the bleach solution, that is the mass of the sodium hypochlorite in the bleach solution has been given and the volume has been given. We have to find out the concentration of the bleach solution or the concentration of the sodium hypochlorite in the bleach solution. So at first we have to calculate the number of moles of sodium hypochlorite, which is given by mass divided by molar mass. Substituting the values, that is 63.3 divided by molar mass of sodium hypochlorite is 74.44. On dividing this, we will get the number of moles will be equal to 0.85 moles. Now we have to convert this volume into liter. Dividing this by 1000, we will get 0.3 liters. And coming to the molarity calculation, that is concentration of the solution is given by number of moles divided by volume in liter. Substituting the values, that is 0.85 divided by 0.3, we will get the concentration of the sodium hypochlorite will be equal to 2.833 m. This is the answer to this question. Hope you find this video useful. Thank you.